Hello everyone, myself Haziq Kirmani, and this is one more video of our series of most expected archives, and this is one of the most famous and controversial problems that was given by JEE Advanced in 2014. Let's see what it has to offer. We'll see a rocket is given in a gravity free space, so there is no gravity, nice, and the rocket is moving with acceleration 2 meters per second square in x direction. The length of the chamber was given as 4 meters. This was 4 meters. Okay, this was 4 meters. A ball is thrown from left with this velocity, and at the same time another ball is thrown at 0.2 in minus x. This one, suppose this is A and this is B, and this is the rocket R related to the rocket. Okay, both of these speeds are related to the rocket, so you don't need to worry about the like outer speed of rocket, whatever that is. Okay, these are with respect to the rocket. At what time another ball is thrown in minus x direction, okay, from the right end related to the rocket, the time in the seconds when the two balls hit each other. So you will say, so basically this is our chamber and that is 4 meters, and one ball is here thrown towards right 0.3, and one more ball at the same time 0.2. Fine, and there is an acceleration 2 meters per second square. So let's solve it like the lift problems. We'll say we have one particle here 0.3 and it has a minus acceleration of 2 meters per second square. Okay, the acceleration we give to the lift with respect to the rocket, isn't that the same concept of lift? Same. But what about this 0.2 and again 2 meters per second square for this also? So can we say what is relative velocity of A with respect to B? Basically A with respect to B. So B is at rest, for example. We'll say that is initial velocity is 0.3 of A minus 0.2. Basically that will add up to 0.5 meter per second in right direction, isn't that? Because B is at rest. For B as an observer, A is moving towards B with 0.5 meter per second. Nice. And what is the acceleration? You will say, sir, acceleration of A with respect to B is 2 minus 2, that will be 0. So there is basically no acceleration. Okay, there is no acceleration. So we can directly say, okay, we'll directly say how much time will UAB take to cross this 4 meter? It will be, sir, 4 divided by 0.5, that will give you 8 seconds. And this was the answer that was given by JEE Advanced in that year. Fine, 8 seconds, simple problem. But then the twist comes due to the wording of the problem. Okay, some students challenged this answer key of 8 seconds, saying it was given the length of the chamber inside the rocket is 4 meter. Okay, this was given as 4 meter. If you see, okay, I'll just move it here. Fine, if you see here, okay, this is the wall of the rocket, and see the wall was also given here, isn't that? The wall is also there, and the chamber is given to have 4 meter space inside it, and the acceleration is there given of the rocket. So if you see particle A and this wall, what is the acceleration of the wall? You'll say, sir, that is 2 meters per second square. Fine. With respect to the wall, what is the velocity of this particle that was given with respect to the wall? That is 0.3 meter per second. So can we say initial velocity of A with respect to rocket is 0.3 only? That is given. What is acceleration of A with respect to rocket? Okay, that is 0 minus 2. So we'll say minus 2 meter per second square. Fine. Let's make an equation. Okay, basically we are checking, is the wall of the rocket touching this particle or not? Can we say S is ut plus half of at square? Yes. Okay, in this relative equation, S is SAR, U is AR, velocity of A with respect to the rocket. Acceleration is acceleration of A with respect to the rocket, basically. Fine. And this is distance or position of A with respect to R. So we want this position to be 0. Okay, that should be initial velocity 0.3 multiplied with t minus 1 by 2 into minus 2 is minus 1 t square, isn't that? That will give us 0 is 0.3 minus t into t. So two values of t we are getting. One is t is equivalent to 0, the second one is t is equivalent to 0.3 seconds. Now we know why this value is coming, because initially when this particle was thrown, there was no distance between the rocket's wall and this position, fine. And after some time, because this was the velocity of the particle A with respect to rocket, okay, but the wall is also accelerating. So initially it separates, but after some time the wall also strikes it again. That is the case. In 0.3 seconds only the wall is striking it back. It is the problem now, because after this time this velocity will do nothing, because the wall is going to drag this particle A with its own acceleration, that is 2 meter per second square. Got it? So this is the twist in the problem, fine. Now how to calculate the new time? Isn't that the initial time was how much? 8 seconds. Basically we are saying in 8 seconds these two particles are meeting, but in only 0.3 seconds this wall is striking this. So our calculations are wasted, because we just took ideal space. Basically our rocket was having an infinite space, but that is not given. Only 4 meters are given, isn't that? That is the problem. So what to write? We'll say this particle is 0.3 meter per second initially with respect to the wall, and afterwards it is just being dragged with the wall, isn't that? So this particle A has no essence in real. What about the second particle that is having initial velocity related to the rocket to be 0.2 meter per second leftwards, fine. Can't we say that this is 4 meters now? Basically this wall is striking this B particle now, because the A will be dragged. So effectively we can say we have to find the time in which the B is just striking with this wall, isn't that? Because A has no essence now, it is being dragged with the wall. Finally you have to meet the wall anyway. So you will write one more equation. You will say, sir, what is the velocity of B with respect to this wall? That is taking this direction to be positive now, that is 0.2, isn't that? Velocity of B with respect to the rocket is 0.2 minus 0, basically, because initially there was or this was already given. Velocity of B was given with respect to rocket to be 0.2 meter per second, fine. What is the acceleration of B with respect to rocket? We'll say, sir, that is 0 minus 2, so minus 2, okay, 0 minus minus 2, because this direction we are taking negative now, so this was minus 2, isn't that? 0, you know the formula na? I'm not saying like random things. I hope you are understanding everything, isn't that? So can't we say acceleration of B with respect to rocket is acceleration of B minus acceleration of rocket? That is how much? That is acceleration of B, that is 0 minus minus 2, isn't that? So our relative particle B has a relative velocity of 0.2 and has an acceleration of 2 meter per second square. So how much time will it take to travel this 4 meters, basically, isn't that? We want to travel to another wall, we want to reach this wall now. We'll say, sir, 4 in that direction we are taking the distance to be positive is UBR. What is UBR? 0.2 T plus half of A. What is A? ABR, T square. So from here you get an equation, T square plus 0.2 T minus 4 is 0. If you solve this quadratic, you will get times value as 0 minus B plus minus root of B square, that is 0.04 minus 4AC, so one more minus, so plus 4AC is 16 divided by 2A. So basically, because you have to approximate the answer, so can we say this is nearly somewhat 4, isn't that? Plus minus 0.2 minus times, isn't that? Now can we say divided by 2? Basically we just took it to be 4 only, isn't that? 16.04 is somewhat near 4. We cannot take minus sign because time cannot be negative, so effectively we got somewhat around 3.8 divided by 2, that is somewhat 1.9 seconds. So in the nearest integer, that would mean time is 2 seconds for the collision of these two particles. And that was the second key that was released. I hope you got the twist of this question. What was the initial key and what was it challenged to? And this is a very beautiful problem, and it is usually found in all the books. So best of luck with this problem. Thank you so much for watching. Subscribe for most expected archive series.